I'll begin by introducing all our panelists, and then I'll tell you just a couple of words about the format. So the general topic is performance, optimization, profiling, that kind of thing, but feel free to ask related questions. Ideally, you will ask most of the questions or all the questions, but I have a few prepared just in case we don't have enough. And panelists, please, let's try to keep the answers relatively short, and if there's need to elaborate, then we can. So just to briefly introduce everyone, let's start with Karl. Karl Zygmunt is a software engineering manager at Microsoft. He spends a lot of his time guiding .NET Core development on GitHub. He's responsible for a lot of areas like networking, collections, and other APIs. Sergey Bykov is the founder of the Orleans Distributed System project at Microsoft Research, and he's been working with it across the organization. And now he works in the Xbox division, and he tries to improve developer experience around cloud services and distributed systems. Federico Lois is the co-founder of two companies, Core Values and Code-alike, and has been working on performance for the last 10 years with a focus on low-level optimization on CPUs and GPUs. He worked on banking software, database engineering, and everything in between. Andrea Kinshin, PhD, is a JetBrains Rider senior developer. He's the author and maintainer of benchmark.net. He's working on a .NET benchmarking book, a Microsoft MVP, and his research includes mathematical biology and bifurcation theory. Yes. Rafael Rialdi is a Microsoft MVP for developer security. He works as a software architect, consultant, and speaker. He's an active organizer of multiple developer groups in Italy, and he works on an enterprise project with a focus on code generation, as you have seen in his talk today, and he also works on cross-platform mobile and IoT development. So this is our team of panelists, and you can ask them, again, anything you'd like about performance, optimization, distributed systems, and what it has to do with performance. You can ask in Russian, and I will try to translate, but we will try to keep the conversation in English because three of our panelists don't really speak Russian. So, does anyone want to start with a question? You see, this is why I prepared some questions, but still, just in case, I thought, yes, Dino, thank you.
The question is, I was about to tweet, so I ask you the question. Here in your bios, everyone is, Federico in particular, 10 years of optimizing, 5 years, 8 years, 20 years of optimizing. How long you keep optimizing code?
I will repeat. I just repeat the question. So Dino is asking, like all of us are saying, we have been optimizing software for the last 10 years, 15 years. How long can you keep optimizing something? Okay. Yes, you wanted to answer, Federico, please. No.
This one does.
Yes.
Let's put it this way. Until I'm dead. Optimizing is like the most addictive stuff that you can do in computer science, period. It's just, you're getting 20%. Awesome. And then, oh, I got another 10. And then, oh, I got 2x more. And it's like, every day is like this. So, it's addictive.
Okay, I would agree it's addictive. Anyone else?
The question is, how bad the code was at the beginning?
And how much you add during that time, right?
And how much?
How much code you add, right? You know, software is growing. You add more and more, and guess what? You introduce new bugs, you introduce new problems, new performance problems. Someone has to go after that and go and fix it.
But then you go distribute it, and you have extra dimension of optimization.
Okay. Cool. Yes. I will repeat the question.
С некоторых пор Microsoft стала использовать открытый код, в том числе большое количество контрибьюторов. Насколько изменилось качество кода с момента, когда Microsoft проприетарным кодом занимался, и открытым. Вот качество конкретных контрибьюторов, вот, я понимаю, что их просто стало больше, извините, что их просто стало больше, но процент качества вот, профессиональных программистов Microsoft и обычных людей, скажем так.
I will translate. So the question is, ever since .NET Core has been open sourced, and Microsoft is seeing external contributions as well, the question is what happened to the quality of the contributions? Are we still seeing just professional contributions from Microsoft developers or other kinds of contributions as well? And again, as it relates to quality. I think Carl is best equipped to begin answering this.
So I'll start with the number of it's here to weird myself. The number of contributions actually from external contributors is in CoreFX I would guess half, probably 50%. I think there has been some even statistics recently. There have been some statistics announced on GitHub, and actually even from Microsoft on .NET blog, so you can look it up. But I think it was actually a pretty high number, between 30 to 70% is external contributors. I know it's a wide range, but it's non-trivial.
And the quality?
And quality, well, we don't let in anything that is bad quality. Let me put it this way, right? You know, with code reviews, with tests, you make sure that what you take, like we own it, or you know, or not that we are the only owners, but if I take a fix, a PR, I have to make sure that it's something that is up to the standards. So we don't take something just because it came from someone external. The quality bar is the same as for internal engineers.
Cool. Over there. If you can get there.
It's a long road. To the top.
Doop, 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 doop. There we go.
How do you do performance review performance-related code review? You won't be able to compile that code on the fly in your head, right? You need to somehow harness, test the code. How do you do that? Do you really run your performance suite, full performance regression suite for each commit?
All right, that's a question again for me, I guess, or someone wants to? Huh? Okay. So, no, we don't run the whole performance suite for every PR. We have internal system that runs on regular basis, and from that we catch regressions. On top of that, if we take a PR that is performance sensitive, we make sure that whoever filed that runs the tests and ideally adds the tests, so we can actually ad hoc run them on machines. So.
He asked about the code-generated code, right?
Not the generated code, but the PR.
But you can see why you...
Well, suppose you did accept the PR, right? And later, like a week later, you did realize the PR quality, performance-wise, is not that good. How would you deal with that? Do you find the developer and try to catch him, or what do you do?
So first of all, we make sure that that type of stuff doesn't get in, right? You know, we have code reviews and they are pretty thorough. So we know that, oh, you're messing up with something that is, perf sensitive. We basically ask that person, like, oh, you need to run these tests, and we're gonna, if it's not clear that it's a winning thing, we're gonna run them ourselves as well. Like whoever does the code review. Stephen Taup on CoreFX, of course. Who else?
Andrei, you were talking about performance regression detection. So you don't take a lot of contributions externally, but what do you do internally? You probably don't run all the performance regressions for like every PR, or do you run for every PR the whole suite of performance tests?
Yes.
Okay, so they.
In fact, we have different kinds of performance testing. We run a small suite per each branch, but we also run a huge set of tests daily.
Cool. Okay. Yes.
Yep. Hello, everyone. So I have a pretty simple question. In theory, when you need to start worry about performance, I understand why I ask this, because from my point of view, sometimes you should carry upstart, because, for example, if you're gonna make an app that's used by regular users, like, I don't know, App Store or something, you should care about performance, but no, because nobody likes when your app is slow, when your app is draining your battery or anything else. But for example, for enterprise, there are probably different standards, and they probably sometimes has to use your software because this is enterprise. So the question is when you should start worrying, when you should start thinking about performance, when you start, I guess the more correct question is thinking, because you probably don't want to optimize upstart because you need to, your system is really dynamic in terms of developments. Things come and go, especially at the early stages of development, but you need to start thinking, and what's the right point?
Sure. So when do you start thinking about performance, especially in an enterprise scenario? Yes. Anyone?
I guess the problem is that you have different layers.
Could you hold it a little closer?
Yeah. The problem is you have performance problems at different levels. So at the very beginning of the architecture, you should imagine what is going to happen when the system is completely developed. Otherwise, you could really miss something. So, for example, if you have a very high number of IOs because you are using external process to do some kind of elaborations that you need, and you could do that in process instead. Your architecture can be literally very, very different. But of course, going into the bits since the very beginning is generally wrong. I mean, there is no, it makes no sense to go into the inner details since the very beginning. It is, in my opinion, very use case dependent. So you should anticipate where are you going to improve the performance with the development going on, and that's it. I mean, you should start from caring about the architecture things immediately, and leave the code details later when the development is in progress. That's my opinion.
Anyone else? Yep.
I do agree with that, wholeheartedly. I want to just try to specify it in a way that you can actually think about it. There's some products that do not need proactive optimization, period. You can have like a single point of failure that it's going to be your performance problem forever. So you just deal with that and you're done. So for that kind of products, you can be completely reactive. Probably you will have like 2 hours of downtime until you figure out what is going on, and probably 6 more. But if you hit that threshold, it's because you hit it so fast that it doesn't matter if you plan for it, because you are not going to generate the scenario where you are going to be there. If on the other side, you know that you are going to get such a scenario, then you started wrong, because you have to start performance first. And to start performance first means that you are not going to commit to any decision before you actually have a POC that you can actually load with very high load to actually being able to test what the limits are. So to the question itself is, first you have to understand where you are. If you are starting a product, you don't have enough information to actually make a proper decision about it. And that's mostly where we usually make the wrong turns. We decide to do things that ends up being over-architecturing and making you lose not only time, but also response time when the shit hits the fan. So essentially what I'm trying to say here is, first you need to realize if your product is going to be, if you can get away with reactive performance analysis. If you cannot, then do the other thing. But to respond to the question is from day one,
Yeah, but I think also the asker is interested in knowing like what is the criteria for a product that would have that you would be able to afford to be reactive on. Like what is a product where you can just think about it later and when shit hits the fan, fix it. Does anyone else want to chime in?
So I would like to say that I agree that you have to worry from the beginning. From the beginning about performance, and the first step should be set performance goals. I cannot do it for you. I don't know what your application is. It really depends on that. If your users are okay with 10 seconds delays, that's fine. If they are okay with 6 hours of not having the service, maybe you're fine. You are the one who can set those limits. But you have to set your performance goals, set the limits, and then think about your architecture. Is there some weak points that might make me miss the goals? That's something you want to prototype, you want to look into. If not, you go, and of course, ideally have some performance tests. Again, if it's 10 seconds, you probably don't need performance tests. All you need is that from time to time you run it and check it. But if it's like 100 milliseconds on a web server, you might need some automation or, what Andrei does, right?
I have a different take on this. Maybe because you spent 20 years optimizing performance, my approach is much simpler. There's a rule I learned from this guy, Rico Mariani, right? So he phrased it, I heard it many years back. If you engineer, you're supposed to measure. If you don't measure, you're not an engineer. To me, that's the very simple rule that you have to measure what you do. You don't have to necessarily have goals because you don't know, like your product is being designed. You don't know what to optimize. Maybe you don't need to optimize, but measuring, I think, is the first step. To know what you have and how fast it runs.
If you don't measure, you're not an engineer. That goes.
I think that's a very easy rule to remember because I still remember it after.
It goes on Twitter.
He used it to say measure.
Right.
There was an internal version too. Yes. If you don't measure, you're not an engineer.
Yes. Yes.
Hello. I have 2 questions, and I don't know. I will try to ask both. The first one is about telemetry and in Microsoft. Do you use it to understand does customers have some problems? And I'm not talking about crash dumps, about some medium problems with performance. Do you make some regular analysis about it? And the second question is about the results of performance tests. My bosses want the one single number. Every day they want one number, but it doesn't. It won't show the real state of application because it's wide, it's business. So what do you think about this one number that talks about how is performance today? Thank you.
Yeah, that's the great questions, I think. Let's start with the telemetry, Microsoft people.
This is a simple answer. It depends.
Yeah. So actually, unfortunately, I don't know how much details I can tell about that stuff, which means I will rather be safe to keep my employment with Microsoft and not tell any details. But yes, there are many ways how we actually look at performance and how we measure it, how we get continuous information, and that applies to almost any product.
If I can just add a bit, which would be completely non-confidential because you can all just see it on your computer. If you look at Visual Studio while it's running, there are a couple of ETW sessions in the background which get created by a process which runs next to Visual Studio, and it monitors a lot of stuff about Visual Studio performance. What they do with it internally, they won't tell us right now, but the monitoring is there, and it collects more than just crash dumps. Crash dumps are for bugs, but delays, response time, CPU usage, these things are also collected. So you could guess maybe what is being done with it. Sergey, you want to add?
No, I think that is true. And again, the first step is to collect and measure, because if you don't have data, you can't be intelligent. And then I think different product groups do it differently and go to different length. If you talk about .NET or SQL Server or Windows, they have different processes for that. There is no simple answer to everything.
Okay.
What's important as well to kind of notice that there are differences if you are on something like Visual Studio, when you have basically customers UI and you measure that, or you are service like, I don't know, Bing, Office 365. And or if you are a platform like .NET, because .NET itself doesn't have direct users, right? It's everywhere, and lots of the performance troubles are caused actually on the up stack by the applications themselves. Now we have to take out of that, okay, make heads and tails without investigating every single application. So in the platform it's more difficult than in the applications, but answer is to both yes.
One more thing, since for the second question, you are in trouble with your bosses, and for the second thing, I would suggest you to create a number giving weights to the other numbers that you internally are measuring. So that's the only way. You have backend, you have front end, you have external processes doing some background job and so on. So just assign a weight to the importance that these external processes or this business logic are doing inside your application. Then you make the multiplication and sums, and you are done. And so your boss will have just a single number.
They will forget the formula. Yeah, but wait, Andrei, you have a regression test. You told us about a very detailed process you follow, and you have managers, I think. So how do you represent all these results to your management? You can't see his face, but he did some. He makes beautiful faces.
Yeah, we don't have such kind of management. We don't have to present our results to anyone. And in fact, our workflow is very simple. If you don't like performance of our product, like ReSharper or Rider, you just create an issue on your track. Not like ReSharper is slow, please fix it. But a more specific issue like this feature takes a few minutes. I want to. It would be great if it will work instantly. Okay, next other users vote for this issue, and after it has a few hundreds of votes, we are trying to fix it and make it instantly. That's all. We don't have a global number which indicates state of our success. We just fix issues.
Okay, Federico, I think wanted to say something because you did a lot of stuff on Raven, right? And you did want to represent it.
I actually was going to focus specifically on the question, which is how do you represent this stuff to your boss?
Okay.
Well, first step, if they really insist on a number, just made it up. The next time he comes knocking, you said, okay, did you saw that number? Yes, I just made it up. How? Oh, I used this formula. But you know what? It doesn't make any sense. Fine. Why? Just make them watch this stream and you will explain why. Now, how could you approach this so you can actually have the backing data when he comes knocking the door? And you say, oh, how did you derive this number? Oh, what I did was like, these are our critical services. So I put them in this bucket. These are the other critical systems, the non-critical systems, so I put them in this bucket. So, well, these non-critical systems are like very unimportant. So I multiplied by 0.00000001. The other part, it's a problem because this is an average. Because this is an average, it's actually showing pretty good numbers, but they actually doesn't mean anything. Now, I do have the raw data. Do you want me to show you how all the different services behave on a power law distribution? Yeah. Okay, let's do this. And now when you show him, is it true that this is costing that much? Yeah. Can we fix them? Oh yeah. Done. And now this is how this is supported. This is supposed to be shown to the boss. So it's a question of education more than a question of how do I condense something into a number. I know it may sound controversial to say I made it up, but essentially whatever you do to actually derive that number is a technical, I made it up.
Yeah, I'm sorry to interrupt. Let's try to keep the answers a little shorter. Yeah. But I think basically the answer was you can't really condense it to just one number. Question over here. Do we have the mic somewhere? Microphone? Yes, over there. All right.
Hi.
Yes.
I have a question. How do you understand that software is slow and need some performance improvements? I understand. Make it clear. For example, we have some report, multi-page report of all the parameters of oil refinery. Yes, for 10 years. Yeah, last 10 years, and it is generated for 10 minutes or for half an hour. And 4 of 5 our customers will say, we understand, yes, for the 10 years, half an hour, it's okay. And the fifth will say, no, we can't take it. Half an hour is too long. Okay, we need 15 minutes and not the longer. What should I say? They all like a half an hour and you should be satisfied, or what?
What? So, okay, so how do you...
Or we should spend another 15 years of optimizing performance to make the report for 15 minutes, not for half an hour.
I think it can be even generalized to a bigger problem, like how do you get these metrics out of your users? Does anyone want to say something?
How do you set the goal? That's basically the point. So the problem is how to establish. Depends how many customers are complaining. That's the point. I mean, we hear from Microsoft very often to say, bring me customers to justify the effort. That's basically the problem. It's just one customer is enough for you to do something. So did it. Just do something and remove the sleep that you put 15 years ago. That's basically.
Remove the sleep that you put in 15 years ago. That's what he said. That's what he said.
So, but I think everyone put sleep.
Go ahead.
I would a second satisfaction, right?
I would actually say that when you have such a problem, just tell them like, okay, you want it fast, you want 15 minutes. This is how much it's gonna cost. Translate into cost, and most customers will decide like, am I willing to pay the cost for that value? Either they run away, or they accept what you have, or they give you the money to make it better. And the customer can be your boss, it can be boss's boss, someone in your company, or it can be external company.
I think it also helps to have a little bit more data. For example, if there is a way with reasonable cost to understand the distribution, where is that time spent? Is it compute? Is it I/O? If you can break it down, maybe it's slow I/O, that's why it's slow, but compute actually is 20 seconds. Then you can present this as a choice. We have a problem with data store, and you can invest in it if you want, or organization. Because you have more data, more context. You just say it's slow. Or
okay, just before you, I'm sorry, we do have a question online, right? So it's a question to Andrea Kinshin as the developer of benchmark.net and Rider. Do you use benchmark.net to develop Rider? How many
and vice versa.
And vice versa. How many benchmarks do you have? How much time all the benchmark takes? Do you fix bugs using benchmarks?
Yeah, I use benchmark.net primarily for performance investigation. So we don't have any benchmarks in our performance suite, because we don't need it. we have a lot of huge problems, huge degradations, and micro benchmarks are usually just a part of regular investigation. There is no need to automate it and run it every day. Also, benchmarks takes too much time. Some of my benchmarks takes day to get a good level of precision. So that's all.
Okay. Here too.
Good.
No, it's the same. The same response.
Give him the mic.
It is the same response here. You use it for investigation mostly.
Mostly.
Other tools for doing regression.
Mostly used for investigation. Other tools for regression. Yes.
Hello, everyone is asking about performance, so to make it fair, I'd like to ask about code generation. I am playing with code generation in my pet projects, and I found that there is no easy way to do it, because the only way I have found currently is a project on GitHub, which is making weird things with custom MS build targets, with new .NET Core CLI tools, and so on. So I'd like to ask if you think there will be some easier way, like we are currently developing analyzers. It makes just same thing, but you have to click a bubble to make it happen. So do you think we can have something similar, but running in some automated fashion? For example, like LLVM middleware is doing currently.
If you are hoping someone is developing such a tool, the answer is not. Basically, no one is going to improve the things in this field because it is not something that generally is considered familiar or simple and should be made available to anywhere. Code generation is something that comes when you grow as a developer and you want to begin making something more advanced. It's not something that everybody can do at the first experience. So it will, in my experience, all the tools that I created, I searched before on the internet if there was someone who was doing something similar, but I never found something broad that can help me. If you look at, for example, the expressions that we have seen during the session, they didn't even cover all the whole C# language. So there are things like asynchronous and stuff with a weight that cannot be done with the expression unless the tweaks that I normally use to do that. So the way you can measure the generated code is exactly the same that now you have for the general code. So basically you spend a huge amount of time in generating stuff. I say huge, but you know that it's not that huge. So you spend some time in generating the code, in loading the assembly if you use Roslyn in memory and prepare all the stuff. And once you have that delegate, you measure it the same way that you measure any other pieces of code of your application. If there will be, I guess, not enough developer population to justify tools that are specifically address the generated code, in my opinion.
But we already have some analyzers. You just could write the same thing, but which is running automatically during build instead of being run it by manually.
It will be better a unit test because generally you want to write code that is generated on runtime. So the window of measuring is not during the build time, but during the runtime.
Folks, yeah, I think this could be a very interesting discussion for afterwards. Let's let other people ask questions. Yep. We had someone over there, I think. No? Yes, over here. Yes.
So Andrei, in his talk, spoke about performance culture in the team, that everybody must be aware of performance. But do everybody in a team must be skillful in performance because it is a large time investment?
Wow, good question.
The problem is the maturity of the developer. I mean, if someone have the basis, the real basis, and understand the code that is produced from the language that you're using, if you understand the memory, if you understand the processes, that comes automatically. I mean, you have basic understanding of the architecture of Windows or Linux. You know what is going on when your code gets executed. That's the real question. Not only the performance-wise, but also memory-wise, for example.
Yeah, but where do you stop, right? I think that's...
No. When do you need to inspire your teammates to learn the different performance techniques, like JIT optimizations and other things?
So yeah, that's what I'm saying. I think like you have to stop somewhere. All of us have a certain amount of knowledge, and one thing we really like as developers is to force everyone else to know all the things that we know. And so what I don't know is probably not important, but what I do know, everyone has to know. That's how it works. So
can I add something?
Yep.
A very good thing that you can do in that case is if you have someone that is actually pretty skilled into optimization, what he should be doing is every time he changes code and it changes because of a specific reason, he just left like //perf. I did this because this and this and that. So the next time when someone that is not as skilled on that, he's going to see that code and he's going to say, I'm not going to touch this because I have, and then I have to say why I touched this. So two things may happen. There are people that do not care about performance at all, and it's fine. And they can be excellent builders of features. There are other people that probably are interested, but they never had anyone to ask. So those guys are typically going to see that code, and they're going to say, oh, this is this technique. Let's figure it out what it is doing. Or let's go ask who wrote this. So it's a good way to actually motivate the rest of the developers to actually start to taking a look and understand when they're going to change code, that code is performance sensitive.
On Stack Overflow, there is a very nice piece of code that is very bad to read, and in the comments there is a counter, and then a comment that says, if you fail to improve the performance of this piece of code, please add 1. And the number is extremely high.
Andrei, do you want to just briefly answer how you enforce performance culture?
I think performance culture is more about attitude, not about technical expertise. So if you write a feature, you should care about its performance. You don't need special skills, just check how much time does it take. Okay, if you think that it's enough, great, just commit to the master. If you think that it's too slow, you should fix it or ask a performance guy for it. But it's about an attitude. You should care about performance. And the main point that all of team members should care about performance on the same level.
Okay, thanks.
Next question over there, please. Oh.
From this side, the question is, the topic of this roundtable was profiling optimization, and what I see, we really focused on optimization area. And now I'm going to ask you the very rough question. So if we compare optimization process with digging the ground, that profiling is kind of to find the exact place where to dig. So do you guys know, can you share your experience where you start from more or less stable steps of finding exact hotspot in your application, or you consider the profiling like an art. So you can't actually teach how to profile properly, or is it something in my, I don't know, is it a talent or it's just a job?
Do you wanna?
I guess that the problem is just to make a sort of continuous research of the hot path. And you can use tools, of course, for this. So you have a performance profiler that can identify a specific path that is hot. And once you identify that and you try to optimize, you will discover that there are other hot paths that before they look at the very innocent and not very relevant to performance ones. The problem is that going on in improving the application becomes jumping from one area to the other, because not immediately you will see all the hot paths at the same time. So it becomes more or less a problem of understanding what's the best tool, because the profiler behave very differently depending on how they are created, if they are sampling, if they are instrumenting. So it really depends on the tool you are using, and often I found that using more tools at the same time is a good advantage in understanding which are the real hot paths.
I just want to briefly add that sometimes the product is so bad, you are in such a bad place that you can do whatever. You can use any profiler. It can be very slow and expensive. It can be very fast and efficient. You will always find something to improve because everything is so bad. But in a mature product with good performance culture, you can run a profiler for 3 days and you will not find something very slow. Like every function showing up in the profiler takes 0.05% of the time, and there is nothing to look at anymore. And I think this is another sort of question. So how do you improve performance when there is no obvious thing anymore?
Can I add to the art part of the last one, and then I can continue with that one. No, it's no art. Let's put it this way. The only difference between someone that has been doing this for 10 years and you that has been starting is the bag of tricks. Is the ability to find out, to generate a proper hypothesis and be near the spot where you are going to be. The ability to figure out that, oh, I have enough data to actually make a decision. And that is usually the hardest thing. When your data is confident, you can be confident enough about your data, so you are able to take the proper decision. That's the only difference. Also, if you have been working with someone that is skilled in performance for like 6 months, probably you have 80% of his tricks already. Because those tricks are like, you do it all over again every single day, 10 times a day when you are taking measurements. It's not something that it's not something different. So this is the scientific method. You measure, you analyze, you act.
All right, maybe next question.
One last point about this.
One
of the hardest part in finding something that is going wrong with the performance is when there is an excessive number of threads running. So if the application for some reason is using too many threads, especially if they are created manually, that can happen more often, you will not find almost anything inside the profile. I don't know if there are newer tools that can identify this, but I ended up in understanding in some application, just looking at the performance counter, that the number of threads were excessive, and it was the case to reduce them. And when we began in lowering these numbers, the application perform so much better.
Next question, folks.
Hello. A question about a dream. How do you think the fashion of today is machine learning? How do you think when it will happen, when you write some codes in Visual Studio or Rider, and it underlines your codes and says, wait, are you sure, do you want to write it like this? Because we have a huge amount of a huge code base in GitHub, and we know it will slow. It will 90% slow. So when it will happen, and how do you think which problems lie on that way?
Can you write analyzers to detect performance issues automatically? Yeah.
So maybe you can write analyzers, but I think the general question is the same like halting problem. Like, can you write an analyzer that will tell you that your program is wrong? It's a halting problem. You cannot, right? You can have some things that will tell you like this is really bad, but honestly, if the APIs are well designed and things, you don't need that. And in my opinion, like actually in Visual Studio we already have like underlying that, hey, this is slow, this is hot path, and that stuff when you run the performance, when you run it on the profiler. That's probably as best as you're gonna get. That it highlights to you like this is where you spend your time, go and optimize it. That's my opinion.
Machine learning is probably going to help in one specific thing. It is having good heuristics. The ability of being able to look at something and probably, and I mean, we have like a lot a lot of time until probably something like that. We are able to do it consistently for every domain that a professional programmer can do. But it's not going to replace your needs for performance. It's just going to help you in the same way that Visual Studio is helping you to write code today. So it's not something that it's going to be so like, oh, this is like the day and this is like the night. It's something that it's going to grow incrementally with you and for you and specialized for you more than it's something that is going to solve all our problems. That's silver bullet.
Do you want to say something? No? Okay. We don't do it. That's his answer. Okay. Next question, please.
Please, no machine learning.
Well, I agree. My question is mostly inspired by Federico's speech on .NET performance tricks. And, well, the question is quite simple. With these tricks, the code starts to look more and more like CPP code. And yet, it will change with the new framework, updates, and so on. Why just don't use C++ library instead of code?
I'm going to go to see it like this. I love C++. I love C#. I love the way that C++ is evolving right now, which is, okay, we know we have to write all this boilerplate to actually being able to match the productivity of other languages. So we build constructions to do that. On the other side, C#, it's taking the other way around, which is, oh, we have this and this and this. Oh, we maybe can add this and that to not only be productive, but to also fall in the pit of success, performance-wise. So the question is, today, you don't need the performance of C++ for like 99.9% of your code. Actually, it's like would be like 98% of your code. So it's more or less, why would you use one and why would you use the other one? It's just programmer's preference at this point.
I want to answer your question.
In your team, how much people understand your hacks and how they work? Maybe it's still better to just hide it from the code base. That's all.
Let's put it this way. Understand my tricks, or the tricks that we do at the lowest level, probably around 30% of them. Know enough to know that they don't have to touch certain routines, or if they do that, they have to ask and provide facts about how they change them 100%.
Remember the comments, right? So he puts comments in there. Don't touch this. Talk to me if you want to change this.
And it's actually a good idea, because think about it. You're going to look at this code 6 months from now. So in 6 months, you have Core CLR 2.1. Now, some of your tricks are going to be obsolete. Some new tricks may exist for doing the exact same thing. Are you going to touch everything? No, you're going to change those that actually regress. So essentially what you do is like, perf, by 2017, 12th of May, this, if you use a switch here, it doesn't inline. Period. It may inline the future. Yeah, maybe.
I just want to add one sentence. I personally believe that if a hack can be done, it should be done as low level as possible. So if you can solve the problem in the platform, if you can solve the problem on a compiler level, you should go there instead of trying to work around it. It will eventually bite you in the ass.
Yeah, I'm horrified by this whole discussion, to be honest. Because in a distributed system, we have enough complexity of trying to figure out what happens over the network. If we have hacks that work today, don't work tomorrow, that would be a nightmare. So I would stay away as far as I can from hacks in distributed systems case.
But we should remember also the roles that I have C++ and C#. They act in very different domains. I mean, C++ is a language that is very good on compile time, but when you go to the services at runtime, it lacks of metadata, it lacks of many tools that we are used to use normally during the runtime. So, like generic set templates are totally different beasts, and you cannot use one for the other. So the developers should really pick the one that is more appropriate for that specific topic. If you want to make code generation, please don't use C++ because you end up in poking assembly instruction in memory, and that's really a bad hack that is not recommended. On the other side, C# give you a restrict number of problems that can arise from code generation, but you are pretty much sure you have the same compiler, the compiler is on the platform, was installed, and so it's totally different.
I think we can do 2 more questions. Let's try. Yes. Oh, please, go ahead.
My question is quite general. When you're working in enterprise, you quite often encounter a situation when you're aware of some performance or reliability issue that your customer doesn't know about yet. You go to a customer, you say that will be a problem in a month, and he says, I'm good. And then you go to a project manager, you explain the situation to him, and he says, what? Our customer wants some new features. We want more money. Go and generate us some more technical debt. How would you explain to them that performance and reliability is a feature that they need now and not in some vague future?
My take would be let them fail once, they realize that they were wrong, and next time they will listen to you. Because you can't explain, someone who's not listening, you can't explain them and turn them the other way. It's nearly impossible unless you're really, really good. So.
I would put performance and reliability in different buckets, because if something isn't reliable, it's a very different impact on business. Because if your customer is fine with the performance and you want to improve it, that may not be justified business-wise, no matter how strong you feel. But if the business fails, if the system fails, that's a very different conversation. And then if you convince your boss that you want to fix this reliability issue, you can sneak in some performance improvements along the way.
Lie to your boss. Okay.
Educate them.
Educate them.
Okay, let's finally talk about money. Yeah. So the performance tuning process is very poor predictable. And the technical specialist, you probably would never know how much effort you need to reach a performance boost for instance, even in 2 times. However, the financial guys would never invest a penny until they have an definitive idea of how much money they would need to invest into this process. So there is a collision between technicals and financial guys. How would you resolve this collision?
Well, probably I'm the one that can respond to that. Essentially what you do is you generate a project small enough to actually be able to explore what's the potential win that you can get, or what is the time left that you have until a breaking point. You can do that in like 2, 3, or 4 weeks. It's not something that it's going to raise any eyebrow from anyone in the financial office. So it's more a question of if you really want to do it, if you really want to have that data and then act on that data. Because if you're not going to act on that data, then you have just thrown money. So as we are talking about money, that's the only way you can do it. It may happen that the output of that exploratory process is you don't need to do anything about performance at all. You can grow at these organic levels for like a year before you can ever notice that something is wrong. Or it can be like, oh, we are dropping things and we didn't know about it because we are already crashing. Or it can be, oh, to fix this, oh, we can get a decent improvement in probably 1 month. Or we are gonna need like a year of working to actually being able to achieve the targets that we are gonna need to capture that particular client. So it's more a question of how you frame the process more than if you can justify it.
Let's do one more question then. Really?
Can I make a suggestion? A suggestion to read the papers that are were published for Facebook and from Netflix about the architecture and the way they tried to solve the performance problems. They are very instructive. For example, Facebook migrated a good part of the code from PHP to C++, and Alexandrescu was with the guru guy from C++, created a sort of automatically generated code to make this process as smooth as possible. And on the Netflix part, all the part that they use it with the containers. So it's a good reading. If you have to sleep, sleep. No, I would strongly suggest you to take a look and see what are their experience.
Do we have one last question? Yes.
Yeah, the last question will be, what if you don't know, or what, not don't know, but what if the code is optimized and you don't know what you need to do to make it more optimized, but the client wants it? How to react in this situation? Because you look at the code, you see that it's optimized, that you cannot squeeze more performance, and what to do, what approaches to take, how to react in these situations.
I'll just ask them how much money they're willing to pay for this optimization.
Yeah.
Because it's, in the end, it's cost, right? So if you have data, if it shows where you spend time, yeah, you can do more research if they pay for it.
Yeah.
All right, sorry, yeah, we are out of time. Thank you all so very much, and thank our panelists. Thank you, folks.